Hi class, good to see you today. Today we're going to be looking at lesson 1-5. We're going to add and subtract rational numbers. What that means is we're going to actually be adding and subtracting fractions. Dun, dun, dun. And we're going to be specifically looking at mixed fractions, okay? So we're going to be looking at how to add and subtract positive and negative rational numbers, fractions. We're going to use the number line to model addition and subtraction as a movement or distance between rational numbers. So before we do that, I want us to look at how we can model fractions with fraction strips. So modeling isn't us posing, looking off into the distance, our face being put on New York City's or skyline or billboard. That's what I'm trying to say, us modeling for a billboard. No, it's none of that. Modeling with fraction strips, modeling in mathematics is using a tool or some sort of representation of how we can better understand the material and visualize it. So we're going to have our fraction strips here. So we have a fraction strip. This whole value here is 1, and we can split this 1 into eighths. We could split it up into any fraction that we want, but this whole eighth is the same as 1 there. You can see that they're the same width, or pretty close to it. I was meaning to make this the same width. I should make it slightly smaller. There we go. Okay, so it is the same width. It is the same. Okay, so we can see that there are 7 of these 1/8. 1, 2, 3, 4, 5, 6, 7, 8. There's 8. 8 of these makes 1. So 1/8 would just be one of them. Okay, so that's how we split it up into fractions. So how can we model using these fraction strips? So on Monday, Cameron swam 2 3/4 mile and Kate swam 1 5/8 mile. How much further did Cameron swim? So we can see Cameron swam further, but how much further did he swim? So we can split this up using fraction strips. Show 2 3/4 as a fraction strip. So this is 2 3/4, and this other one is 1 5/8. 1 5/8. 1, 2, 3, 4, 5. And the other one is fourths. So we want to know how much further did Cameron swim. So that would be the difference of the two. So it is going to be this region here is going to be the difference. That's how much further Cameron swam. So how could we find that? So we want to take 2 3/4 minus 1 5/8. To do this, we have to have a common denominator, and the reason for that is because we need to understand how many 1/4, how many 1/8 go into 1/4, or how many 1/4 go into 1. So visualizing this, we could take our strips and fill in the gap here. So we can see, and these are slightly off, but they are the same width. We can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 eighths. So Cameron swam 9/8 of a mile further, or 1 1/8 miles. So we've modeled that using our fraction strips, but how could we understand this better using our fractions here? So we want to find a common denominator first. So 2 3/4, the common denominator is 8. So we will multiply the bottom times 2 and the top times 2. Multiplying the top and the bottom by 2, we're just multiplying it by 1. 2 over 2 is 1. So we have 8 over 6 minus 1 5/8. Couple strategies we can do here. We can change these mixed fractions into improper fractions, and that's the method that we typically will do. There's other strategies, but we'll just cover one strategy. So we will multiply 8 times 2 is 16, plus 6 gives us 20 2 over 8 minus 8 times 1 is 8 plus 5 is 13 over 8. So when we take the difference 22 minus 13 over 8, we have 9 over 8, or 1 and 1/8. So this is why we have to have a common denominator, because we're working our smallest unit here, our smallest way that we broke it down is 1/8, okay? And it so happened that our final answer is 1 and 1/8, okay? So this video is going to be a little long, so if you have to pause it and stretch, that's a good idea, okay? So one strategy here, we need to find the sum or difference of -3 1/3 plus 5 and 5/6. So we first want to come up with a common denominator. Common denominator, we'll just call that common denominator is 6. So we multiply the bottom times 2, the top times 2. And you should have done this last year in 6th grade with Miss Anna, and I know that you did because she is pretty awesome. All right, so 3 times 2 is 6, 1 times 2 is 2, plus 5 and 5/6. Now we want to convert these mixed fractions into improper fractions. So we have 6 times -3 is -18, or is 18 and 2, so we have -20 over 6, plus 5 times 6 is 30, plus 5 is 35 over 6. So we can simplify this to -20 plus 35 over 6, which is 15 over 6. And typically we want to rewrite our question as a mixed fraction since our question started off as a mixed fraction. So this would be the same as 6 goes into 15 2 times. 6 times 2 is 12. So then we have 3 left. And 3 over 6 is 1/2. So we have 2 and 1/2. Okay? Yes. All right, let's look at this other type of question that you will see. Here we have a decimal and a fraction. If our fraction, we can easily convert that into a decimal, I suggest that we do that. So let's rewrite this. 8.4 plus, because minus a minus becomes plus, 9 and 1/2 is 9.5. So now we need to line up our decimals here. So we can take 9.5 plus 8.4. We are lining the decimals up vertically. This is something that you would have done in elementary school. Notice our decimals are lined up vertically. So we have 9.9 and 8 is 17. So 17.9 is our answer. And please box your answers in this case. Okay? So if you could go ahead and try this one on your own with the dolphin, type your answer in. And you should have gotten -7 and 1/4, or you could write -7.25. Either way is fine. All right, this next example, we're going to use properties of operations to add and subtract. So the force of gravity added to the force of thrust is the combined force at work on a model rocket. It's kind of like our basket with the balloons going up and the balloons going down, okay? What is the combined force in newtons of the rocket? So hopefully our combined newtons are a positive number, so our rocket will go up, okay? If it isn't, then our rocket is coming back to the ground. Okay, so we're wanting to combine these two. So we need to take the difference of the two, or we're just combining the two, sorry. We have 1 and 1/2 plus -0.49. And I'm using a different color because 0.49 is a negative number. So let's convert 1 and 1/2 into a decimal, since that is, we can easily see that is 1.5 minus 0.49. So to subtract these two decimals from each other, we want to line the decimals up. 0.4 and 9. Okay? There is a 0 here, 0.50. So to do this, we are going to cross 5 out. Bring the 1 over. 10 minus 9 is 1. 5 minus 4 is 1. And hold up, something's not right here. What's going on? Oh, we are, yeah, this is right, but 5, we're crossing the 5 out. That is 4. And then we bring the 1 over. 10 minus 9 is 1. 4 minus 4 is 0. And 1 minus 0 is 1. We bring our decimal down. So it is 1.01 newtons. All right? Go ahead and try these on your own. All right, this first one I'll work out, and then the rest of them I'll just write the answers for you. So this first one, let's convert this to a fraction, -2 and 1/2, or since this is 10, we'll make this 5/10 minus 5 6/10. So we need to change these both into improper fractions. So we have -25 over 10 minus 56 over 10. So we have -25 minus 56 over 10 gives us -181 over 10. So we will have -8 1/10 or -8.1. Either way is fine. Okay? The answers for B, we have our -2.9 or -2 9/10. And C, you should have -56.9 or -56 9/10. Okay? Either way is fine. Ruby wants, so this is our last example. Ruby looks over the edge of her boat and sees fish 0.4 meters below the surface of the water. If Ruby holds 1 meter long net at 0.5 meters above sea level, can she reach the fish? Explain. So here is the sea level. Okay, so we have the sea level here on the number line. Sea level. Okay, up here is the edge of the boat. So the net, okay, Ruby holds a 1 meter long net at point. So this is how high Ruby is above sea level. Okay? We then have 0.4 is how deep the fish is. Depth of fish. So we need to find this distance here. How far is this distance? Because she has a net that is 1 meter long. So is her net long enough to reach the fish? So what we need to do is we need to take that distance. And a way that we can find distance is by taking the absolute value of 0.5 minus -0.4. We're taking the difference of the two. Absolute value of 0.5 plus 0.4. Absolute value of 0.9 is 0.9. Stay positive, right? It is a positive number. If you didn't take the absolute value, in this case it actually didn't matter, but to find distance we take the absolute value. So she's 0.9 away. Can she reach it? Yes, because 1 meter is longer than 0.9 meters. Okay? All right, this last one, go ahead and try on your own. The answer should be 15.25 feet. Okay? Let me know if you have any questions. Sorry this video is so long. And remember, mathematicians aren't supposed to be models. We model with fraction strips. All right, I'm done. See you later.